Okay, this is Dr. Williamson. I'm doing another problem. It says here, what factor, by what factor does the rate change in each of the following cases, assuming constant temperature? It says reactions first order in A, and A is doubled, a concentration of A is doubled. Second order in B, and the concentration of B is halved. Reaction is second order in C, and concentration of C is tripled. So first thing we got to do is write down the chemical reaction and then its rate law. So let's do this. Let's go let's do it in black. We're going to go A plus B plus C goes to products. Why did it do A, B, and C? Because it implied I have three reactants: reactant A, reactant B, and reactant C. I don't know what little a, little b, and little c are. That could be a 1, a 2, and a 3. I don't know what the balancing coefficients are. But to solve this problem, I don't need to know what they are. But next thing I need to do is pay attention to this. It says that it is first order in A, second order in B, and second order in C. So I'm going to write down the rate law. Go R. Let me do that. I intended to do that in black. R is equal to K A. I'll put the exponents back on. I'll put the exponents on there in just a moment. B and C. And it says it's first order in A. I'm going to go ahead and I'm going to put a 1 there. We don't normally put the 1 there. It's like doing algebra and writing x to the 1 power, but I'm going to do it as a teaching tool. Okay. It says it's second order in reactant B, so I'm going to put a 2. And second order in reactant C, so I'm going to put a 2. Okay. And then let's take a look at A. A reaction is first order in A, and the concentration of A is doubled. So that implies we're keeping everything else constant. So R will be proportional to the concentration of A, and we doubled its concentration. And we know that it is first order in A. That means we have an effect of 2 to the 1 power. That means the rate of the reaction will be doubled. If it's first order in A, we keep everything else constant, but we double the concentration of A. Here, I put a 2 there. That means the rate of the reaction will be doubled. That's how you interpret it. That's how you can interpret it. Okay. So let's take a look at letter B. A reaction order is second order in reactant B, and B is halved. So we're keeping everything else constant. The rate constant, K, A, and C. So in this case, the rate of the reaction is proportional to the concentration of C. And here we halved it. It's 1/2 of what it was before. And it is second order, right? Second order. Well, what's 1/2 squared, right? Well, that's going to be 1/2 times 1/2, or that'll be 1/4. So if the concentration was 1 molarity, and I change of B, 1 molarity of B, and I changed it to 1/2 molarity of B, I would expect the reaction rate to be 1/4 of what it was originally. So if it was 10 molarity per second, it would be 1/4 of that, right? Just given illustration numbers. The reaction order is second order in reactant C, and C is tripled, right? So keeping everything else constant, I'm only changing concentration of C. I changed the concentration of C to be 3 times whatever the original concentration was. And it is second order with respect to C. That'll be 3 times 3. No, 3 squared, right? Okay, right, 3 squared, put it there. And that will be equal to 9. It'll be 9 times as fast. Does that make sense to you guys? Be 9 times as fast. Okay. Now let's say these are the numbers, and let's just for practice, what would be the units of K, the rate constant? Well, if R was measured in molarity per second, we would have R equals here A to the 1 power, B second order, C second order, and that'll be molarity per second. That's R. A will have units of molarity. B will have units of molarity squared. C will have units of molarity squared. Right? And then this molarity will cancel with one of these molarities. And I will have 1/seconds divided by molarity squared times molarity squared is molarity to the 4th. And I will end up with molarity there to the -4 seconds to the -1. And if I were to type it, right, I would type K has units of molarity, the -4 seconds to the -1. Okay, that's not what this problem was asking for, but I threw that in as a bonus problem. All right, hope that helps.